There we go. All right. All right. Here we go. So, today, we'll be able to knock this out in 15 minutes probably, I think, that we can knock today out. Okay? So, we're going to talk Heron's formula today. Heron's formula, we actually should have done first semester. It's an offshoot of the law of cosines. Okay? It's a way to find the area of a triangle given the three side lengths. Okay? Normally, we find the area of a triangle by going 1/2 base times height. Okay? But today, we're going to be able to do this as as I said, it comes out of the law of cosines. We can find the area of it just given all three sides. Okay? So, there's some important documents out there in the world. Okay? And some of those documents have something called a preamble. Okay? It's kind of like the introductory part of the document. Okay? So I'm going to say that the preamble for the Heron's formula is this. The semi-perimeter is half the perimeter. Okay? So semi meaning half, perimeter meaning, how do we find the perimeter? That's area. How do we find the perimeter? Add up all the sides. No matter what the figure is, the perimeter is the sum of the side lengths. Okay? Well, we're dealing with a triangle, so we have to add three numbers together and then divide it by 2. So, and the symbol for the semi-perimeter is the letter S. So S is going to equal side A plus side B plus side C, all divided by 2. Okay? That's our introductory phase to Heron's formula. Okay? So, Heron's formula then tells us that we can use the semi-perimeter to find the area of the triangle. So if I take the semi-perimeter, multiply it by the semi-perimeter minus one side, multiply that by the semi-perimeter minus the second side, multiply that by the semi-perimeter minus the third side, and then take the square root of that, that's going to give me the area. Okay? And that's all Heron's formula is. Okay? Which is cool when we need to find the area of a triangle. Because now we don't have to worry about getting a perpendicular height. Excuse me. Okay? We can just go, this works for any triangle. Okay? It works for isosceles triangles, it works for obtuse triangles, it will work on right triangles too, but we don't have to have that right triangle. Okay? Which makes it a little nicer. Alright, so find the area of the triangle given the following conditions. Well, my side lengths are 11, 7, and 9. So the first thing that we need to do is we need to find the semi-perimeter. 11 plus 7 plus 9, and then we divide that by 2. 11 plus 7 is 18, plus 9 is 27. 27 divided by 2 is 13.5. Okay. So the area here of this triangle is going to be 13.5 times 13.5 minus 11 times 13.5 minus 7 times 13.5 minus 9. $13.5 is 13.5. 13.5 minus 11 is 2.5. 13.5 minus 7 is 6.5. 13.5 minus 9 is 4.5. can't do it. I was trying to move it down so I could see a little better, but nope, not going to bother me. Not going to bother my OCD. So I want to be in there. And 13 points. So this gets me the square root. Oops, tap the brakes. Got to get the old marker back on. The square root of 987.1875, which is, I get an area here of 31.4195. And if we had units attached to these, like let's say they were feet, okay, then we would be in square feet because we're dealing with an area. Okay? Questions on Heron's formula? No? Okay. What I'd like you to do now is I would like you to find me the area of number 2. All right, so my semi-perimeter here is going to be 53 plus 43 plus 72, all divided by 2. So what's that? 96 plus 72. Hold on, I gotta get on it. Escape, enter, escape, clear. There we go. What did I say? 96 plus 72 is 168. So that gives me a semi-perimeter of 84. So then my area is going to be 84 times 84 minus 53 times 84 minus 43 times 84 minus 72. And I got to take the square root of all of that. So 84 is 84. 84 minus 53 is 31. 84 minus 43 is 41. And that one's 12. Right? Okay. So if, I'm just saying if we were to be exact, we would want to leave it in radical form. Okay? So if I'm looking at 84, 84 is 4 times 3 times 7, right? 31 is just 31. 41 is just 41. And 12 is 4 times 3. Now I say that because 4 is a perfect square. 4 is a perfect square. And 4 is a perfect square. So those two together, because we're taking the square root, those would be a 4 on the outside, because they're a pair. 3 and 3 would make a pair, and so that would be 3 on the outside. And then that would leave me with 7 times 31 times 41 on the inside. So that would be, what is 7 times 31 times 41? 8,897. So this would leave me with 12 times the square root of 8897. Would be the exact. Okay? You probably rounded it though and got me an answer of 1,131, oops, 0.89, not just 0.9. Right? Okay. The difference is this last blue line is exact. Okay? Simplifying radicals. Okay? This maroon line is rounded. Okay? All right. What I would would like you to do is I would like you to help out Linsmeyer Farms and figure out how much fertilizer I need to buy for this particular field. Walk me through the process of this problem. What do we first need to find? So we first got to find the semi-perimeter, and that's going to allow us to find the area of the triangle, or the area of the field, right? Okay. Then what? After we have the area of the field.
You then figure out how many times 15,000 square feet.
So then we need to break the area of the field up into 15,000 square foot chunks. Okay. And then once we have the number of chunks, multiply it by 2 because we want to put the fertilizer on it 2 tons per acre. Okay? All right, so let's do that. So first we said we have to find the semi-perimeter. So that's going to be 1,100 plus 850 plus 1,600. Okay? And then that's going to all be divided by 2. Okay? So then that gives me a semi-perimeter of 1,775. Yes? Bless you. Okay. So then the area is going to be 1,775 times 1,775 minus 1,100 times 1,775 minus 850 times 1,775 minus 1,600. So that is 1,775 times 675 times 925 times 175, which is I got 4,40393.556 square feet. Yes? Okay. So then that we said, now we have to figure out the amount of 15,000 foot chunks. Okay. So we're going to take that 44,0393.556 and we're going to divide it by 15,000. And that's going to be 29.3596. So there's 29.36 chunks, and each chunk is going to get 2 tons, right? Oops, I wrote that wrong. I forgot the decimal point. There we go. There we go. Okay. So how much fertilizer do I have to order? I'm going to need to order 58.72 tons of fertilizer, which I get it. It's way off. Okay. But I just was going with numbers there. Okay. Because really, I might only order for that field. I gotta think now. This one here divided by 43,650. I might only order 20 total tons. Not even. I would only order maybe 10 tons on that field. Okay. Good. That's all that there is to Heron's formula. Okay. All right. That might be something, FYI, Heron's formula might be something you want to put on your note sheet for next week. Wink, wink, nudge, nudge. What's up?